this section will be basically interstellar bodies, planetary bodies. So we'll be looking at things like supernova, stars, black hole, dark matter, gas clouds. And although all of these items are vast in scale, in fact the diversity of the number of objects that can be named from this is small. Yet we take one more step along, say 2 more steps along to geological evolution, and the number we can name is much greater. So we can say mountains, so like tops on them, rivers, deserts, rocks, volcanoes, cracks, etc. And then the next one down when we get to life and all its species, and then technological evolution, computers, Heinsberg beams, and fish, cakes, and Nike shoes, etc. So the number of objects here is much wider than it is there. But of course, the evolution of this particular item contains all these items. The evolution of one of the most complex objects in the universe, which is a brain. Drawn in black, grey at the bottom of the third row. Just colour it. Now it's absolutely incredible to me that when you're flying in a plane at 35,000 feet, you can't actually see a human being because they're too small. And yet inside the head of one of those tiny human beings, there is an organ which has the capacity to understand abstracts like time, space, relativity, and have within it a model, not a perfect model, but quite an accurate model of the entire universe that created it. There's the brain. Now, it'd be too long to go into the reasons behind why the brain is the way it is now. And to be honest, I don't want to remain on the scientific.
So that's the limit of it. Now what I want to do is try and draw a kind of sine curve travelling through that now. So come up through the quantum level, and it intersects, comes down through the human level, and intersects, goes round through the galactic level, and intersects, goes up and down into the visual end of the visual universe, and intersects. Now, looking at that sine curve, which points intersect our line of scale? They intersect at the quantum level, the human level, the galactic level, and the visual universe level. 4 points with that curve as we've drawn it out there. Interestingly enough, as I explained before, these are the very points where we get this figure 100 billion. 100 billion, 100 billion, 100 billion, 100 billion. That's 100 billion galaxies, 100 billion stars in each galaxy, approximately, 100 billion cells in your brain, etc., etc. So, with those points, could it be that the line we're existing on here, or the time that we're travelling along, this line of scale, somehow intersects another type of time, or another type of dimension, which allows in certain scales, large scale structures to occur. what we have with the brain, very complicated organic pattern recognition device. Now, unlike a computer, which is turned on and off and typed in periodically, it's a very organic system which is constantly, from the moment you're born, receiving inputs. There's two eyes at the front, which feed it with visual stimuli. We have two ears, left and right, feeding again with inputs from the environment around us. We have nerve endings throughout the body, from the spine, and feed us with physical inputs. We have taste and smell, molecules fed into receptors which stimulate us as well. And perhaps there's argument saying we might have a little bit of a magnetic sense and a few other things, but generally it's being fed with information permanently coming in. And I don't know about you, but I find that my internal voice, or at least the idea of thinking, is permanently going as well. It's a permanent cycle of thought going on inside. So once that thing starts off, it begins thinking and it begins storing information. And the mystery about how this thing stores it, the goal here, is that it's actually stored with these, which are neurons. Here are the dendrites coming off. This is the axon, this long bit. Like so. Terminal synapse. And the great mystery about this is that all the molecules in your body over a lifetime all change. Cells die, new ones are made, and yet you still retain your looks. Change, but you still retain a general look of who you are, and you also retain your memories. Somehow this thing can store information. It can store it because of the cycle that was stimulated within those neurons. It remembers them and associates them with other things, and those patterns, the ability to recognise patterns, is very important. And there are approximately 10 billion neurons inside this brain, and about 10 times as many glial cells, which makes about 100 billion connections in there. And that number, 100 billion, and that pattern of branching occur again and again inside the universe at different scales. To give you an example of that, if you take a large scale map of the universe, computer simulation showing the position from a fictional position outside of the universe, and you plotted every supercluster and galaxy, you'll get something that looks like this. Kind of branching. This is all in red, by the way, at the bottom of the drawing. Sounds like a cookery program, which is kind of what it is. Cut this gas mark. Right. So there it is. It's like a lot of branches. Is it possible to perceive other dimensions than the 3 dimensions of space that we know, plus 1 of time, which comes off like this, t? So obviously at 1 second the cube looks like this, and then at 2 seconds the cube looks like this. So we could animate a dimension of time and understand it. As the cubes travel off into the multiverse. So taking this notion of, so now we've got this idea, sorry, this is getting a little bit more advanced now. So we have this idea of 3-dimensionality, and here is the universe with its as we travel through scale. Now, the concept I'm considering at the moment in this drawing is, could scale, is it possible to see the dimensions and the dimensions of space that we know, 1 of time comes off like this. So obviously at 1 second the cube looks like this, and then at 2 seconds the cube looks like this. So we could animate a dimension of time and understand it as the cubes travel into the multiverse. So take this notion of, so now we've got this idea, sorry, it's a little bit more advanced now. So we have this idea of three-dimensionality. And here is the universe with its as we travel through scale. Now, the concept I'm considering at the moment in this drawing is, could scale, is it possible to perceive other dimensions than 3 dimensions of space that we know, plus 1 of time, which comes off like this t. So obviously at 1 second the cube looks like this, then at 2 seconds the cube looks like this. So we could animate the dimension of time and understand it as the cubes travel off into the multiverse. So taking this notion of, so now we've got this idea, sorry, it's getting a little bit more advanced now. So we have this idea with three-dimensionality, sorry, it's getting a little bit more advanced now. And here's the universe, so it's as we travel through scale. We have this idea with now three-dimensionality at the moment in this drawing is good. And here's the universe, it's as we travel through scale. Now the concept I'm considering at the moment in this drawing is good.
There is again 100 billion galaxies. So each unit of scale or each category contains the next category. Seems to enjoy this 100 billion for some reason. 100 billion units. And it's only a small act of faith to imagine that our whole visible universe is simply a bubble of expansion amongst 100 billion other universes in a multiverse.
Of intensity and pattern revolving around this 100 billion units. Why should that be? And what is the nature of scale? One thing that science has taught us is never to take anything as read as the way, in the way the common sense would have it appear to us. So, I'm not a scientist, but I want to take a model now which describes the visibility of other dimensions, or the impossibility of viewing dimensions bigger than what we have potential to view. I didn't explain that very clearly, but... So if we lived in a flat world of 2 dimensions, then our world would look like this. Draw this here with some foreshortening. There's a flat plane. We'll call that plane flat world. Okay, so here's flat world. And I exist, let's say, here in a flat world. I exist in 2 dimensions, x and y. Here, x and y. Now what would happen if a 3-dimensional object was to pass through my world? We'll take 2 objects, a sphere and an upside-down pyramid. Like so. And they're going to travel through our world. And I'm here, and they will pass by me. So what would happen is, as the sphere touched the square, I'll do an animation of it down here, through the flat plane, first of all, I would see a dot. And then I would see, after that, about a circular boundary travelling towards me. And then I would see the boundary would get bigger as we approach the diameter of the sphere as it passed through the plane. And it would get to its maximum dimension here. Let's call that M. Then it would begin to get smaller. So we can see there, that was the passing of a sphere through time in our 2-dimensional world. That's how it would appear. Now, in mathematics, it's possible to imagine a world with 3, 4, 5, 6, 7, 8, 9, 10, 11 dimensions. But of course, it's very difficult to visualize these things, just as it would be impossible for this person in the flat world to visualize the 3-dimensional object. It would have no comprehension of this 3rd dimension. But it could tell from measurements of the effects of that thing passing through its 2-dimensional world. It could make some calculations on the nature of that object that passed through it. To give you an example of just the pyramid going through, again it would be a point and then a triangle, which would get bigger and bigger and bigger and then totally disappear and then totally disappear.